SCG Labs! Ah! Shoots, brah, up out. What's going on? My name is Tosh Dalday. This is STG Labs. Welcome to class. Physics! What up, dudes? I've got a pocket protector and a bunch of highlighters. That makes me officially a nerd, and I can teach you now. Alright, so check this out. We're going to be solving this problem right here. I've got a kind of a cliff of something over here, and I've got a block or a pulley that comes over the edge, and I have a block, and I'm going to call this M1. I'm going to call this block M2, and then this there's going to be a rope connecting these two. There's no friction, I'm assuming, between the ground and M1 over here, so I'll be happy with that. Alright, so let's check this out. Let's figure out what the acceleration of M2 is. And what I'm going to do is I'm going to call positive Y, or positive X in that direction, which kind of does an interesting thing. It makes this the positive X direction. I know that you're thinking, wait a second, that's going in the vertical direction, and why are you calling it X? And my answer to that is, you know, the pulley, it kind of turns this coordinate system. Because if you think about something going in the positive X direction here, and think about moving this block this way, then this should also go in the positive X direction as it goes down. Alright, then what I'm going to do is I'm going to do sum of the forces in the X direction is equal to mass times acceleration in the X direction. What forces are on here? Well, I see that there's the tension, and then there's the weight of it, and then there's the normal force. This is all of number 1. All right, now on this guy, there's the weight number 2, and then the tension going up. All right, I'm going to sum the forces in the X direction on that one. The only force that I see going in the X direction is the tension, which is equal to M1A. I'm going to sum the forces in the X direction over here, and I have some of the forces in the X direction equals mass times acceleration in the X direction. This would be mass of 2. The forces that I see over here, there's a negative tension going up, negative tension, and then there's a W1 going down. So I've got a plus W1, or W2, I'm sorry, equals mass 2 times acceleration. Let's see, W2 is mg, so I've got mg minus t, that would be m2g, equals m2a, and t is actually m1a, so m2g minus m1a equals m2a. I want to solve for acceleration, so I'm going to go m2 equals m2 plus m1 times acceleration. Drop that acceleration down, so I've got acceleration is equal to m2 over m1 plus m2 times gravity. Good. I wanted to make sure the units worked out, because m2 divided by m1 plus m2, that's a ratio. That would be like kilograms being divided by kilograms. It's not going to give you any kind of unit, it's just going to give you a number. So this is just some kind of ratio that is depending on gravity. Now, let's kind of think about this. If M2 were really, 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 really big, in fact, if M2 were really big, so big that it almost made M1 obsolete, then essentially this thing, you can kind of almost consider that M1 being 0 in comparison to M2. And then you would have something like M2 divided by M2 times gravity. Well, I guess in essence what you could do is, or maybe instead of saying M2 is so big, let's make M1 so incredibly small that it's a little piece of paper. It's not even a piece of paper, maybe let's make it an atom that's hanging off the edge of the stick. Essentially this M2 will just fall with an acceleration of gravity. I'm liking this equation as we go. What if M1 were so huge and M2 were really, 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 really tiny? That would be like M1, let's pretend it's the Titanic. And M2, let's say I'm hanging off the edge of the Titanic. what's the acceleration? Now this is of course assuming there's no friction between here and here. But the acceleration would probably be very, 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 very small. Because if m1 in the denominator got really big, then that would be, acceleration means it's going very small. So I'm hanging with this thing. Shoots, bro, up out.